What up, guys? Today we're back, programmable controls. We're looking at the big scary machine over here, but it doesn't work. So let me tell you how to work. So first off, we look at everything. We come down here, look at it. Everything's already disconnected. Terrible thing. Everything just gone. Everything needs to be reconnected. Probably have censored wires. Everything is gone. Nothing's talking to each other. So how do we do this? Well, we're going to be looking at our documentation to show what wires are meant to go where and how everything's meant to reconnect. We look over here, we're missing a machine. So obviously we're going to have a few loose connections that are no longer there because we have a machine gone. So something else that we need to do is that some of the other documentation that we can find on this machine, which might not be much because this looks kind of custom, we're going to have to bring out our multimeter and look over everything that needs to be redone. Now, if we come back down here, we have a bunch of purple wires, and that's all right, this is chill. But later on, we're gonna be talking about Profibus, and this is how everything talks to each other. We go over purple wires, and they're meant to go over here. Now, some of the things that we need to look at is that, including on this one, it moves already a lot, which is bad. That's wrong maintenance. So how do we do this? Well, first off, we could unscrew this to put it in more and then tighten the screw or something along those lines. Other maintenance things that we can do is that if we look at this arm right here, it's moving nice, but after a while of it working for a long time, things are gonna start degrading. So we're gonna need more oil, grease, or something along those lines. At the same time, calibration. After a while of things moving, things can start getting off. So every once in a while, you're gonna have to check to make sure that your lines are all, make sure that they're all straight. Now, a few other things that we can be looking at is that our air lines. After a little while of them working for a long time, they can start getting brittle and old and things like that. And what we're gonna have to do is replace them. Make sure that whenever you're working on one of these, you find a pinhole, or if there's a crack in it, replace a line. Because if you don't, some things might not start working. Make sure everything's oiled, greased. You should be okay.
Welcome back, guys, to this Minecraft Let's Play. Today here we have the Troubo 200. Now, for the Troubo 200, this specific machine, it is a filthy mess. Just come over here and look. There's dust everywhere. There's loose washcloths everywhere filled with oil and stains. There's loose plastic wire coverings. And even down here, there's broken pieces of wire, just dangling wire on the ground that could trip or even kill someone. Especially for what even is this? It's just sitting here causing an eyesore, especially for different types of cabling, broken material, useless material that's not needed, or material that's not even connected. All of these are horrible examples of maintenance within this workplace. A good form of maintenance within this workplace would be primarily to tidy up everything, dust off the machines, and make sure that everything is working operably. Especially for the network here, with every single one of these Siemens control panels all flipped open, allowing dust to enter as well as water or other fluids or liquids. In addition to pests, given that it's summer, it is more likely for pests such as, let's say, stink bugs, ants, or spiders to crawl into these for shelter. And as my colleague in the last section said, a lot of this equipment likely needs to be oiled, repaired, fixed, or anything else. Especially with wire tabs such as these laying around, these wires must not be doing well. And for the system overview itself, while yes, most of the circuitry on the surface looks like it's completely fine, likely underneath the surface, some of the code has potentially corrupted. While I cannot say that for sure, I can say due to the physical exterior quality, and especially the quality and general stability of the rest of the equipment.
So we were looking at this beautiful masterpiece that's so messed up, and I was noticing that some of the communication wires between the PLCs were unplugged. As you can see, this one has double plugged in right there. This one does not. Neither does that one, but that's also because the fifth system is missing. So after doing a little research, I found out the difference between X1 and X2 plug because I was not quite sure if fixing where to plug it in. Plug it in there, or plug it in there. Now X1 MPI stands for multi-platform interface. Now this can be used for Profinet or Profibus, but X2 is specially designed for Profibus for high-speed communications between PLCs. So if we were to plug it in, we'd plug it in there because I'm pretty sure that this system uses Profibus because that's what the assignment is on. Now, over here, we have it in the multiple point interface. We also have this, looks like almost like an Ethernet cable going out of it. So I'm not quite sure if there's supposed to be a computer plugged in there, but for maintenance, I would definitely check to make sure where that's supposed to be plugged in and what it is supposed to be plugged into. Now, while we're here, I just want to give some attention to the Siemens PLCs because these things have some pretty amazing features. They have one, high-speed processing. Like it can ensure near instantaneous responses. It has network capabilities, like built in. It can work with Profinet, it can work with Profibus, Ethernet, IP. Like it has a lot of capabilities. It's not just the old simple type. We have redundancy and fault tolerances. Advanced PLC support, ensuring continuous operation even if the hardware is failing. So basically it's redundant in some systems where one part of it fails, the other part will make up where that part fails. It has integrations with SCADA and MES systems, and it has motion and process control. That's a lot of amazing features. Now, also while I was looking at this, I saw this thing and I was curious on what it was because I already saw the PLCs, which basically operate the machinery, so I wasn't sure what this was. So when I looked it up, it turns out that this is a tool designed to sharpen troubleshooting skills in real-world scenarios. Basically, it has 16 different fault scenarios covering pneumatics, electrical wiring, and PLC programming. Whether diagnostic failures, wiring circuits, or adjusting system parameters. Trainees gain hands-on experience in resolving complex issues. It's more than just training the system. The SMC TRAB 200 builds technical thinking, problem solving, and adaptability skills, essential for keeping industries running smoothly. It's not just about fixing problems, it's about mastering the art of automation troubleshooting. I thought that was pretty cool, and I also realized that we may be using systems like these further in our schooling that we have not used right now. Or it could just be an older tech and they have newer stuff like it.
All right, guys, that's been my Minecraft overview.